and welcome to Grade 5 Science. My name is Kisa Richards and together we will learn a whole lot more about science. If you like science like me, you will surely have fun. If you don't like science that much, I can tell you, if you put your mind to it, you will have fun and even like it. So, tell your friends, tune in, let's do science. Because science is fun, science is cool, science is awesome. And best of all, science is everywhere. Get your notebooks, get your pencils, and so you're going to learn a lot more about energy, your body, earth and space, and so much more when you tune into Grade 5 Science. So today is our second session, and we're going to continue on the topic properties and changes in matter. But we're going to focus on factors which affect the rate at which a substance dissolves. Good? When we talk about rate, what comes to mind? Good. We're talking about speed, or how fast something happens or how quickly it happens. In this case, how quickly a substance will dissolve. And so we're going to investigate some of those factors today. In fact, two of those factors. But as we do our investigation, as usual, you're going to identify those factors by yourselves. Good? All right, so let's begin. Here we have our materials set up, and as I said, you can try this at home with your cups and drinking glasses and other substances. Good? But today, we're going to work on sugar. As you see, we have our sugar there, and they're all of the same amounts because we're not looking at amounts of sugar. We want to see what factors, right? Maybe, right? Another time. But we want to focus on the water part of it because we have cold water, we have warm water, we have 2 beakers of water at room temperature. Good? So, good. All right, so that's how the water in the beakers are different. Good? All right, so we know that sugar is soluble in water. Sugar is soluble in water. We learned that in the last lesson. So we know that we expect the sugar to dissolve. But we're investigating the rate at which it dissolves. So our first investigation will be based on the water at room temperature in beakers A and B. Good? So we also have a stopwatch here, and you can use the stopwatch on your cell phone if you're trying it. Right? But for this one here, we're going to add the sugar to the 2 beakers of water at room temperature, but this one will remain as it is. We wouldn't do anything to this one, while the second one, we're going to stir it. As we can see, the sugar is dissolving. because it is soluble in water. Is anything happening to this one, the one in A? Good. I'm going to stop here. All right, so let's observe what is happening in these two beakers. In this one, I'm still seeing sugar. And in this one, so in beaker A, I'm still seeing sugar, while in beaker B, I'm seeing only what appears to be water. A little discolored because of the brown sugar we use. Good? So the sugar would have dissolved in B, but not in A as yet. Good. So what factor did we investigate here? Where in A, we add the sugar and leave it as it is, while in B, we stirred the sugar in the water. And here we see all the sugar has dissolved. And in B, the sugar is still there. What was different about these two mixtures? What did we do differently? Good. One was stirred and the other wasn't. So what factor did we look at there? Stirring, or what we call agitation. We agitated the mixture by stirring it. And so the sugar has dissolved in B but not A, because A was not agitated or stirred. Good. So one factor we look at there is agitation. Good. So when we agitate a mixture that contains a substance that is soluble in a liquid, the substance dissolves quickly. And when it is not agitated, it remains as it is at the bottom there. But eventually, as you can see here, the water is starting to be discolored by the brown sugar. So it is happening, but very slowly. All right? Good. If we leave this for a while, by the end of the day, tomorrow, most likely the end of the day, the sugar will disappear or dissolve. Good? Now the next investigation will be based on adding sugar to cold water and warm water. Good? So, what do you think will happen when we add water in these two beakers? The one with warm water and the one with cold water. Good. We know that the sugar will dissolve, but we don't know in which one it will dissolve first. So we really need our stopwatch for this one. Good? All right, so what I'll do, I'll quickly add the sugar. I'll put my spoons in there to stir. I'll add them at the same time, and I'll start the stopwatch, and I will stir them both. I'm multitasking. Or I could have done one at a time too. All right. Good. All right. So I have no sugar in beaker C, which had warm water, but I still have sugar in beaker D, which had cold water. Wow. So, see, we still have sugar at the bottom there, while in this one there is no sugar. So all of the sugar would have dissolved here in about 36 seconds, while in 36 seconds we still have sugar in the cold water. All right, so what did we do different in terms of these two beakers? What was different? Awesome. The temperature of the water was different. So here we had warm water, which is of a higher temperature, and here we have cold water, which is at a lower temperature. So when temperature is higher, it increases the rate at which a substance dissolves. In this case, it increases the rate at which the sugar was dissolved. As compared with the cold water, we still have sugar remaining. So we would have looked at two factors affecting the rate at which a substance dissolves, and in this case, it's sugar. So those two factors we looked at are agitation and temperature. Good? Agitation would be like stirring, shaking, swirling, right? And temperature is how hot or cold a substance is. So one water has a higher temperature than the other. So here we see that agitation increases the rate at which a substance dissolves, while temperature also increases the rate at which a substance dissolves, but a higher temperature. So the higher the temperature, the shorter the time the substance will dissolve. Good? Now, when we agitate a substance, what really happens? In the case of beaker D, we increased the movements of the particles. Remember, matter is made up of particles in a mixture. We increase the movement or the kinetic energy of the particles in this mixture, thereby causing them to collide with each other faster, and new water molecules coming in contact with sugar molecules and causing them to dissolve faster. While in the case of beaker A, where there was no agitation, only the liquid molecules above or around the solute at the bottom there, in fact the sugar at the bottom there, would allow dissolving to take place. And so it will happen very slowly, right? In the case of temperature, the higher the temperature is the higher the kinetic energy of the particles in the mixture. They're going to move about faster than when the temperature is lower. And as they move about faster, there is more contact with water molecules and sugar molecules and causing them to dissolve quickly as compared with the cold water, where the molecules are moving a bit slower, and so you find that it would dissolve, but not as fast as when the temperature is higher. Good? So, two factors that affect the rate at which a substance dissolves are agitation, like stirring, shaking, swirling, and temperature, cold water, warm water. You can also try at home room temperature water, cold water, and warm or hot water, but under the supervision of your parents. Good? For the next session, we're going to look at two other factors. And so, what I want you to get would be your 4 containers with equal amounts of water, a substance that will dissolve. You put them in 4 parts, and 1 part of it, or 1 teaspoon of it, I want you to make it smaller, grind it. Good? So you are more prepared for the next grade 5 lesson to work along with me and do your own investigation at home. Right? So, for your task today, I want you to get a bottle with its cap, add some water, in fact 2 bottles, add equal amounts of water and equal amounts of a substance that can dissolve in the water, and you're going to close the bottles. One you will swirl and the other you will shake vigorously. Then see what happens. In which one of those bottles will the substance dissolve first? And give reason for your observation as well. Good? So that's all for now. And so remember, science is all around us. Goodbye. See you next time.